Thanks, Marianne. Aloha. Yeah, my name is Tommy Haensel. I'm a postdoc at UH Mānoa, and I work in the Indigenous Cropping Systems Lab with Dr. Noah Lincoln. And I've been around in Hawaii for 6 years. Thank you. For 6 years now, 5 as a student, and now 1 year as a postdoc. And for the past 6 years, I've been kind of immersed in this world of Hawaiian agriculture, looking at the soils during my PhD, and then now kind of focusing in on Kona and the Kona Field System. So yeah, thank you all for coming out. Excited to share with you all. Hopefully some of this research hits close to home for some of you, being here in the Kona Field System. So for my PhD work, I mostly studied soils. I kind of looked at how soils develop across Hawaii's big gradients in age and with climate. And with that work, Noah and we developed several spatial models for trying to understand the distribution of agriculture across Hawaii and where these traditional agricultural systems were being conducted. And for these models, we selected them in several broad categories. You have these flooded pond field systems, which are your lo'i kalo. You have more intensive rain-fed systems, which are what you think of with these dryland field systems like the Kohala Field System, the Kona Field System. And then you also have a diversity of these different agroforestry systems as well. And all of them are adapted to the different ecologies and environments that you find across Hawaii. So if we just zoom in on Big Island, you can kind of hone in and see the diversity of different agricultural systems found here. And kind of on a leeward-windward comparison, on the leeward sides of the island, like here in Kona, in red, you get a lot of where we predict that there was a lot of this intensive rain-fed agriculture being conducted. So up in Kohala, Kona, and in Ka'u. But then on the windward side of the island, where it's much more wet, down in Puna is much more rocky. Our models didn't predict that there was as intensive of agriculture going on in these areas. And through historical accounts, we do know that there was a ton of agriculture being conducted there, but maybe not at the scale of these field systems like you find in Kohala or in Kona. What we actually found was that if you look at archaeology for some of these field systems, our model does a pretty good job at predicting where the most intensive dryland field systems were being conducted for hundreds of years. So the most famous is the Leeward Kohala Field System. Maybe you've heard of it or read about it. And then here we have the Kona Field System kind of in our backyard, which has been less studied, but there's been a couple archaeologists and soil scientists who've come out here and tried to look at Kona. And then there's the Ka'u Field System as well, which is less researched. Not as many people have done work there. But they're the 3 big field systems of Hawaii Island. So this is kind of a aerial imagery of the Kohala Field System. You can see all of the kua'iwi spreading for kilometers or miles. So this field system was about 60 square kilometers, covering a huge portion of land in North Kohala. And archaeologists have mapped about 1,400 kilometers of kua'iwi there. So it's just this huge field system which would have supplied food to thousands of people for hundreds of years. Lots, yeah. Big warrior culture out of Kohala. On the ground, it was mostly for the production of uala, but there was dryland kalo, other crops as well. But what research has predicted is that along the kua'iwi, there was rows of ko planted, which would capture the moisture from these. The wind almost comes in sideways with mist, and it would hit these kua'iwi and the sugar cane, and then the droplets would come down and irrigate the crop. So that was kind of the design of these systems. There's also the Kona Field System here in Kona. And also a very similar kua'iwi design, but interestingly, the walls here in Kona, the predominant walls go from Mauka to Makai, which is the opposite to Kohala, where they're going perpendicular to the slope. And there's several theories about their construction, and I'll get into that later. This satellite image is just of the field system in Ka'u Malu Malu, Ahupua'a. And there's a ranch there today, but so much of the Kona Field System is still underneath remote forest, is underneath coffee farms, or has been developed over time. And right here where we are at the garden, we have examples of kua'iwi. If you walk around, you'll see them. And in between the kua'iwi is where these dense plantings were planted for hundreds of years. And it was mostly, the staple was kalo, but there was also uala, mai'a, ko, vauke, all being grown together in these systems. So it was a very mixed system. And then there's the Ka'u Field System, which is much less studied. There's only been a couple studies looking at smaller portions of the field system, and I couldn't really find any good aerial imagery that kind of showcases it, but I do have this LiDAR image here where you can see all of these different kua'iwi almost working as like a matrix of construction along the landscape there in Ka'u. And most of the field system today in Ka'u is on Kahuku ranch lands. And we predict that it probably extended east into Pahala and Na'alehu, but a lot of those regions were bulldozed, and the sugarcane plantations were put in there over 100 years ago. So it's hard to see any kua'iwi remnants in these areas. So those are our dryland field systems. On Hawaii Island, you also get some lo'i kalo in the few windward valleys that you have here, like Waipi'o and Pololu valleys. And there you get constant stream water. You have erosional sediment, which is constantly being replenished and fertilizing the soils there. Makes it ideal for these lo'i kalo terraces. And say if you were to go eastward into Hamakua and down towards Hilo, you get more of these agroforestry systems, which were the dominant form of agriculture. My advisor, Noah, has done a lot of work on the what's called the Pakukui system of Hamakua. And there, up kind of between Waipio Valley and Laupahoehoe, the land was planted with tons of kukui tree and then mulched. And then it was almost this traditional compost method where that kukui mulch was integrated into the soil, because naturally those soils aren't actually that fertile. It's a much wetter landscape where the soils have been leached. So just tons of different traditional methods across the island. If you look at other islands, you kind of get a gradient or a shift towards different practices. On Kauai, it's much more dominant with lo'i kalo and wetland agriculture. Just because of the topography, you get a lot more of these dissected river valleys that are good for supporting these lo'i kalo systems, and then also a lot of agriculture on the colluvial slopes. But once you get onto the flatlands, those soils are super depleted in nutrients. It's a very old island. So that's when you get all of these red soils, which are depleted and much more acidic. So not really very supportive of like an intensive dryland field system like you find here on Hawaii Island. There's a picture of Loikalo in Hanalei, which is on the north portion of Kauai. So yeah, that's kind of just a little background on the modeling work that Noah and I were working on for a couple of years. These models are, they're broadly categorized, and zoomed out, they do a good job at predicting the general areas of where agriculture and what form it was taking. But zoomed in, I feel like it's lacking a little bit. And each place, each moku, each system has their own peculiarities that these models don't really pick up. So kind of my work now is more focusing in on a specific area, which is Kona. A lot of writing here, so I'll try and take away the focus of the writing and just say a little bit about the goals of my work. So about 2 years ago, our modeling work caught the eye of the NRCS, and they saw potential in our models for incorporating into their models, into their ecological site descriptions, and saw that there was this huge temporal gap of Hawaiian agroecology that wasn't being well described in a lot of the ecological site models that the NRCS was producing. So my boss right now, his name is Matt Cocking. He works for the NRCS. He kind of theory crafted this project with Noah with the goal of incorporating concepts from Hawaiian ecology and agroecology into NRCS materials, so into the ecological site materials and their descriptions. So the NRCS produces a ton of ecological site materials, and they provide maps, they provide information on what vegetative communities are found there, what climate, the climatic features of these zones, the soils. And so our role has been, my role has been kind of to bring in Hawaiian agroecology into these materials. Mapped on the left there is kind of what the NRCS has produced. So they map different ecological sites. So for example, here in Kona, there's more than 3, but I have 3 mapped here. These are the 3 predominant ecological sites. So the biggest is this Kona weather Udic forest. And then Makai of that, you have the Kona weather Ustic forest. And in their ecological sites descriptions, they provide a ton of information on the different vegetative states, the soils, and the climate features within that specific ecological site. Also a lot of writing, apologize, but stay with me real quick. So these are just examples of what is actually in these ecological site descriptions. They provide information on the soil, the climatic features, and the ecological dynamics, where they talk about the different vegetation communities that you can find within that ecological site. But when I was first looking through some of these ecological sites here in Hawaii, they actually do talk a little bit about the agriculture that was being conducted here for hundreds of years, but it's not much. So they do mention that areas were extensively altered by humans, placed under intensive agriculture, and cleared with by hand or by fire with the introduction of new plants. But they don't talk about what plants were planted, where they were planted, what these agricultural systems actually looked like, where they were. And it's kind of this huge temporal gap. They they'll talk about the native forest that was there before, and then just the modern day ecological communities. But there's nothing about those hundreds of years of Hawaiian ecology and agroecology that was being conducted. So that's kind of the setting the groundwork for this project. And it was a very broad goal, but it would be very difficult to incorporate all of these concepts across all of the islands and all of the ecological sites. So we settled for a case study approach where we're looking specifically here at Kona's ecological sites. And by by the nature of being here in Kona, I've been looking at agriculture and agroecology here in Kona. So that's what I'm here to share with you, all of the work that I've been doing over the past year. So as some of you may know, Kona has a very unique environment. Huge rainfall gradient, so along the coast, very dry. And as you go up Mauka, you get colder, but you also get wetter. And then you'll hit some temperature, or you hit a weather inversion where then as you go progressively further up, you get drier and drier. And that's overlaid by all of these different lava flows from Mauna Loa and Hualalai, all of different ages. So you have some lava flows which are under 500 years old, and you have some that are older than 15,000 years old as well. So you have all of these different soils that have developed because of that, and all of these different opportunities for different types of agriculture. I guess early on in my work, so kind of in the first month or two, I was reading through historical accounts of agriculture here, reading old Hawaiian history books, trying to think about the almost these traditional ecological sites that would have existed in Hawaii. I don't know if anyone's read David Malo's Hawaiian Antiquities book, but he has a section where he talks about the moku and the ahupua'a, and then perpendicular to that, he talks about these different vau and these kua zones of that intersect through each of these ahupua'a. And kua refers to the back, but it's referring to these mountainous zones. So up on the Mauna, you have these different kua zones to represent the summit, the mountainside, and the lower mountainside. And then you have these vau zones as well, which represent different forest zones. And when I saw this for the first time, I was like, oh, great, I'll make a model of these and try and predict where they occurred on the landscape. And I'll do that for all of Hawaii. But as I continued reading, I found that it's completely different from moku to moku, and even more different from island to island. So you get completely different descriptions for different environments. Like on Kauai is much different than here on Big Island. So had to play with that, and I think that was part of the initial push towards making it more of a case study approach where I focused exclusively on Kona. But yeah, there's descriptions of these vau in Malo's book, in Handy and Pukui books. Kavena Pukui from Ka'u, so she helped with making this kua and vau map in Ka'u. And then Kamakau also describes some of them as well. So this was kind of attempted one time. This was a paper done by Kavika Winter, who's I believe he's a professor at UH Mānoa in the NREM department. And he tried modeling these different vau zone in Kauai. But I realized that the vau of Kauai were very different than the vau of Kona. So there's going to need to be some different approach if I was going to model them. And I wanted to make sure that I got the names correct as well. But inspired by his work, I tried to produce my own model of these vau ecological zones. And I came up with 5, with the vau Kanaka or the realm of man, where man lives and cultivates the land, closer to the coast. And then as you go up, you get to the Val Ama'u, where the Ama'u fern grows. And these are based off of Malo's work. And then as you go up, you get into the Val Akua, where the smaller trees grow, and into the Val Ma'ukele, where the rainforest is, where the monarchs of the forest grow. And then above that, you get above this inversion layer where you get into drier forest, where the Val Eva is. And this is kind of just the first iteration of this model, but it was something to go off of.
Yes.
But one thing that this model didn't take into account is Kona's agroecological zones. So that kind of took me down a whole nother wormhole. Has anyone seen this book before or read this book? Marion Kelly's Namala o Kona, or the Gardens of Kona. It's a really awesome review of different historical accounts of agriculture here in Kona, but then she also reviews a ton of Māhele records, which describe the different forms or where agriculture was being conducted, what crops were being planted, what agroecological zone that each of these different apana were in. So she kind of came up with this initial framework of the 4 zones of the Kona Field System, with the Kula, the Kala'ulu, Apa'a, and the Ama'u. So the Kula at the lowest point, and then the Ama'u as you go up. Awesome picture by Persis Thurston in the 1840s. I think she was Asa Thurston's daughter. So Asa Thurston was one of the first missionaries, and she was in Kailua Bay, and she was looking up at Hualalai from the bay, and it gives you this perspective of these 4 zones and what Kona would have looked like. So that's the Thurston house, and then looking back up the Mauna. So up at the top, at the highest form of cultivation, you had the Ama'u zone. And this was more of an agroforestry zone. And in descriptions, they talk about all of the groves of maia, or plantain bananas. And these were mixed in with the native forest, which would have been a zone for collecting koa trees for wood, or feathers as well. Below that was the Apa'a, and this was the most intensively cultivated zone. And it's here where you get your high density kua iwi, where you get the plantings of really high density kalo. And then in descriptions, they describe endless fields of uala and maia and taro, and ko, sugarcane as well, in every direction. So it was just huge agricultural region. And also, it was placed there intentionally. This was the spot where the soils were most ideal. So if you go above that into the Ama'u, into this wetter and wetter region, the soils become more leached, so not as capable of supporting a highly intensive cultivation. But as you go down below the Apa'a, you get drier and drier, and you can no longer properly irrigate your crops. So it was this sweet spot that Hawaiian cultivators placed their most intensive system. And below that is the famous Kala'ulu, which is the breadfruit belt of Kona. There's still remnant trees all over Kona from the breadfruit belt that have just self-propagated themselves from root shoots. And this region, although it was slightly drier than the Apa'a, the breadfruit trees were able to flourish. And the mulch and leaf litter from those trees was able to support plantings of uala and kalo underneath the canopy. And then below the kalaulu, you get into this much drier zone where it probably wasn't as suitable for intensive agriculture, but you could still do plantings of sweet potato where there was soil. Ipu or gourd was also planted here, and I believe a lot of pili grass was also cultivated here for hale. This was one of the initial models that I tried to construct, where I was trying to predict where these four, agroecological zones were. It was based off of Noah Lincoln's work, where he actually went out and did all of these transects across Kona looking for ulu trees, and found this. He was able to trace the belt through all of these different transects. So my model kind of jumped off of his placement of the kalaulu, assuming that the kula was below the kalaulu and that the apa'a was above the kalaulu. He only predicted that the kalaulu went up to Kalawa in the north and then to Keokea in the south. But then these other systems probably, or these other zones probably did extend all the way into South Kona. So that kind of creates this full integrated perspective of these agroecological zones paired with these vowel zones. In combination, the ama'u actually translates well with the vowel ama'u, literally by name. And then the vowel kanaka, where I originally modeled, overlaps with the kula, kalaulu, and apa'a, where the most intensive cultivation was occurring. So that's kind of our modeling approach, looking through historical accounts and building off of Noah's work. But kind of the second part of my project has been looking at all these different Māhele awards. This was kind of Marion Kelly's approach during her book. But today we actually have really good resources to support this work, where OHA has mapped all of these different Māhele awards in Kipuka, which is one of their online databases. And they've also digitized all of these Māhele awards in Papakilo. So that's kind of what I've been working with to see what claims were being made for specific crops on specific apana across Kona. In case you're not familiar with the Great Māhele or Māhele Awards, it was a period of time in the 1840s and early 1850s where the Kingdom of Hawaii was trying to shift from this feudal system to a land privatization system. Prior to the Great Māhele, the land was taken care and managed of by the king. And during the Māhele, they established several laws that were trying to privatize land ownership away from it all being with the king to private owners. So early on, it was split three ways. 1/3 went to the crown, 1/3 went to the government, and 1/3 went to the konohiki, who were the high chiefs, the ali'i. But in another act later on, the maka ainana, the general populace, was able to submit land claims for the lands of which that they were cultivating and living on. So on the bottom here is some of these claims, what they actually look like. So they have, they would have to do a register. So register where their apana were, their claimed land sections, what was being cultivated there, how big they were, etc. So that's in the register. And then they also needed a testimony. So from a third party, like a friend or a neighbor who could vouch for them and say, oh, I've known this person's land. It's been here since the time of Kamehameha the First, and he's being honest. So it was a testimony saying, okay, they're not claiming too much land. This is their land. This is kind of an example of the work I've been doing, going down all of these different, they're called helu, different cases for land claims. So this is helu 8015 for Aipo in Holualoa 3. And in his register, he describes 3 different land sections. So 6 mala uala make kula, 6 uala gardens in the kula, 6 ma loko ulu, 6 mala inside the ulu, referring to the kala ulu, and then 9 mala kalo mai ka apa'a ahiki ika ama'u. So 9 kalo gardens from the apa'a to the ama'u. So these register descriptions do a really good job at describing what was being grown and where it was being grown. And with the Kipuka database, we can actually go in and georeference all of these different crops and zones. This is an example of the testimony for Aipo. And luckily, this website called Ava Konohiki does translations of these native testimonies. So in the register, it only mentioned 3 sections, but in the testimony, it mentions 4 sections, 3 apana aina, and a house lot or a pahale. And we can look at the award and see the awarded apana. So for Aipo, this is the actual Land Commission award. It shows all the boundaries and what those apana looked like. And in Kipuka, we can see on the map where those actually were. And unfortunately, for a lot of these claimants, such as Aipo, he did not receive all of his claimed apana. So he was awarded the 1 pahale in Holualoa 3 and 1 apana aina in the ili of Laula 1 in Holualoa 2. This is probably the apa'a section, but then he wasn't awarded the mala in the Kala'ulu or in the Kula. Yeah, and that was a common thing for a lot of claimants during the Māhele. I think there was about 14,000 cases made to the Land Commission trying to claim land, but there was only, I think, like 8,400 awards, so that's already cut in half. And of those who were awarded, a lot of apana that were claimed weren't given, so only roughly, say 50% of those who actually received land, they only got 50% of what they claimed. So it was more than just those initial statistics. But for the purposes of this project, with all of these geo-referenced Māhele awards, we've been able to track where kalo was being grown historically, going back into the 1840s. So this is kalo being grown in Honaunau. And we can also look at different agroecological zones that are mentioned. So looking at if the apa'a was mentioned, if the kala'ulu was mentioned, the ama'u, we can do mapping of that as well. And that'll go into refining the models that we're trying to make. So far, this is kind of what I've been working on recently. There's 846 Maka'ainana awards here in Kona, and I've only made it through 496. I luckily have an intern this summer who's great. Her name is Ku Kwanan, and she can read Olalohoi and is helping me with translating a lot of documents. So she's working on those remaining 250 or so awards this summer. And in those 496 that I've looked at so far, I found that 1,553 apana were claimed, but only 748 were awarded. So much like IPO in the example I gave, a lot were unawarded. And of those that were unawarded, it was about 95% were apana aina, so sites that were gardened. And I was trying to predict, how many acres of land were unawarded in just what I've researched so far. With the average apana aina being 2.4 acres, that would be 1,850 acres of land that wasn't awarded. And even if you take a conservative estimate from that and cut it in half, it's still 950 acres that was unawarded. And that still doesn't account for awards that were just outright denied. So tons of land was just left, essentially. So I've been doing models, Māhele awards, and also mapping Kua'iwi from the Kona Field System. Kua'iwi translates to backbone, and it was the backbone of Hawaiian agriculture, at least here on Hawaii Island, where you have all of these dryland field systems. And there's been a decent amount of work done in mapping Kua'iwi here in Kona, but mostly from all of these different archaeological investigations. There hasn't been one project which has just mapped everything. And there's, here's the Kua'iwi in the garden back here. And I've heard theories about the construction of them, that they were used for water management. I've heard theories that, Kona's a rocky place. You need to clear the fields in order to plant kalo. So maybe they were just piled up in these sides and also simultaneously were making boundaries to the fields. But it's probably a mixture of everything. It's probably field boundaries, clearing the fields, water management, etc. And Kua'iwi are the #1 indicator that, okay, there was definitely intensive dryland agriculture being conducted there. So this was going to be a really important component of my work. So here's Amy Greenwell, the satellite imagery. And I've been looking at a public LiDAR database called 3-depth LiDAR, which was published by the USGS a couple years ago. And when I first discovered it, I was in awe because it shows the Kua'iwi extremely well and everywhere in Hawaii. So you can see terraces in remote valleys on Molokai. You can see Kua'iwi in Ka'u, in Kona, in Kohala, and this is all public information. So in GIS, I've just been clicking walls all over Kona. And this is kind of what the result of that is we can actually map all of these Kua'iwi and see the extent of the Kona Field System. And this one's a little hard to see, but because it's so bright. But this is some LiDAR imagery in Honaunau, and you can see all of the Kua'iwi, and this is in a neighborhood. Like, this is where people live. It's just this underlaid Kua'iwi under everyone's houses, everyone's farms, where they're growing coffee. It's all there. And it's just bringing it into visibility to see how big it actually was.
What are your
Yeah.
see all those?
So I think it was about like 9 or 10 years ago, the USGS contracted people to fly their planes over in runs all over the islands. And they shoot lasers down, and then based on how fast the laser gets back to your detector, you know how far it went. So that predicts this surface terrain model all across the surface. So depending on, I guess for these Kua'iwi, that laser returned a little bit quicker than the ground near it. So because of that, you shoot enough lasers, billions of them, you get this digital surface layer, which allows you to see underneath underneath some canopies. If it's too dense, it gets difficult. But the more and more lasers you shoot, the more and more refined your map gets. So there's LiDAR coverage for probably like 90% of Hawaii Island, probably like 80% of Maui, all of Molokai, all of Lanai, but there's none for Kauai, which is kind of interesting. I just think they messed up on their LiDAR runs when they were doing it, but yeah, which is kind of a bummer, but maybe they'll fix it someday. But it also allows you to see areas that were cleared. So like here was a big coffee farm where they've completely bulldozed all of the ko'iwi. So I think it's safe to assume that just based on what it's surrounded by, that there was ko'iwi there was intensive agriculture there. It's just filling in the gaps in knowledge, just based on good assumptions. So this is North Kona tilted on its side. So that's north, this is south. And this is the result of a lot of clicking on LiDAR. You get to see all of these ko'iwi in the scale of the Kona Field System. So yeah, tons in.
Can you point to the killer symptom felt? And then I might actually
Where?
killer symptom.
Sure.
Stutter.
This is the outrigger right here. Yeah, so that's Keauhou Bay. This is Kahaluu Beach Park. Tons of ko'iwi above Kahaluu. And then this is down towards the Hokulea development, Hokulea, a Malka there in Honolo, Ahupua'a. And South Kona as well. So tons above. This is Honaunau right here. Tons Malka from there. Tons above Kealakekua. Probably the densest is above, this is Hokukano, Ahupua'a. But yeah, it's patchy, but it it gives you a good idea of the scale of the Kona Field System.
Where are we?
We are, let's see, I believe we're right here. Yeah, kind of in this region. I don't know exactly, but I think kind of right where my mouse is. So yeah, so far I've mapped 850 kilometers of ko'iwi. But based on all of the bulldozing I've seen, all of the development I've seen, and also areas that are just really hard to see the ko'iwi because it's in such dense forest, I predict that it's at most only 50% of the original extent of the Kona Field System. It was probably closer to 25 or 40%. So comparing it to the Kohala Field System, it was probably on the same scale or even bigger, is what I suspect. This is just a zoomed in look at Kahaluu. And I was amazed at how far Makai the walls go, because I figured, this area is so dry. Like, I found it hard to believe that there'd be tons of agriculture going on there, but they do almost go down to the coast. Most dense plantings up Mauka, but yeah, they do go far Makai. And in this sort of area, development makes it hard to see, but there was, we're pretty confident that there was ko'iwi there originally as well. This is the Ka'u Field System, which was super dense. All of those are all on Kahuku Ranch lands. And again, we suspect that it went further east into Na'alehu and Pahala. It's just we can't see them today because they've all been cleared. So yeah, really awesome field system there. So also, Ann and I, my lovely coworker here at the NRCS, she's she's been going out with me into the field and going out to various sites across Kona in areas that have been undeveloped, because they give us the best opportunity to see this ecological succession from when the fields were left up until today. So part of incorporating all of this information into the NRCS materials is we need to go out and get good vegetation data and soil data and bring that back into these ecological site descriptions. So how we've been doing it, Ann and I, we've been going out into different survey locations in the Kula, the Kala'ulu, the Apa'a, and the Ama'u, and gathering information on all the different vegetation communities there presently. Ann's been helping me with the soil side of things, which is awesome. And we also note, are there any agricultural remnants? Like, are there, like, for example, here there's tons of tea leaf that have probably just self-propagated themselves for 100, 150 years. There's ulu trees, remnant from the Kala'ulu, even pockets of kalo that have managed to survive and self-propagate themselves over all these years. You can still find in various spots of Kona, which is really awesome to see, like that the pigs haven't got them. So, yeah, here's just some pictures from our field days in the Kula. You know, you sometimes find these sweet potato mounds. In the Kala'ulu, there's scattered ulu trees. I don't have any pictured here, but in the Apa'a was where you find a lot more of the kua'iwi. And then in the Ama'u, so way further up, we've been documenting all of the ecologies within all of these zones. And that goes into spreadsheets, which then goes into NRCS materials. It's more complicated than that, but I'll leave it at that. And ultimately, like, we want to do all this across all of Hawaii, not just Kona. This is kind of a pilot project for that, to see what works and what doesn't. And you know, if it works, great, we'll keep it going and look at other islands, other moku. The one challenge we've had now is getting access to a lot of these remote areas of Kona with private land ownership. It's been hard to get access to some of these undeveloped locations. So that's why I was wondering if I could get your guys' help. If you know of any, if you're a landowner or a farmer, or you know, ranchers or you know, large landholders who have these pockets of land that are relatively undeveloped, like, we'd love to come out and perform an ecological survey and get accurate data to incorporate into these ecological sites. So that's one thing that we'd love to hear from you if you have any ideas. So if you do, you can get in contact with me. That's my email. And this is our team. There's me, there's Daniel Bowman, who's the state forester with NRCS. There's Noah Lincoln, who's my advisor, professor at UH Mānoa. And then there's Ann, our lovely soil scientist at NRCS, working with me at the Kealakekua office. So yeah, that's it. Mahalo.
I see first this,
Sure,
and that is the written out, right?
sure, sounds good. Yeah.
I think question on topography.
Mm.
You looked at different slopes. Get this, you know, the hard rocks in Australia here have a lot steeper slopes and probably didn't have the truly even done yet.
Yeah, that's like some of the analysis I want to do, is like seeing, do you get higher kua'iwi density on different slopes? Yeah. Do you get higher kua'iwi density depending on the age of the soil? Like, because some soils, they might be insanely shallow because they're so young, or deeper. So I'll do that analysis in the future and be able to report that.
Background, so cross-reference that with the lava flows that you know about, the things like that.
Yeah.
You're really kind of putting those two together to really powerful to where some of these soils are.
Yeah, flow age is one of the things we can follow already. And then when we're out in the field, we have marked sites that while we're bushwhacking our way to these sites, I'm kind of keeping an eye out on if we're seeing any of these indicated plants. And then when I'm choosing where to like my pole, I try to think about the at this site, not here, like that. But in terms of slugs, I choose kind of pick something that's somewhat like I'm good at that.
Yeah, because sort of this area, very tremendous.
Yeah.
When you say dig a hole, how deep do you build pit soil?
But I was as long as I can go. But honestly, it's not too.
We go until our arms stop.
And so there's a rock there, and I try to, I dig out like a foot or two, so I'll keep moving around until I find a little hole. But sometimes you can bedrock, and that's all you can do.
That could be fun, man.
Yeah. But it's all about describing the trail, the depth of the soil, and where the roots can easily go. Just because you can wiggle your way down doesn't mean it's like regular accident.
Yep.
So does our soils change with the geology of the climate?
Mm-hmm.
Yes, they do. I think like
The age
the age does matter.
is flows coming from Hawaii different from one out.
Somewhat. The chemistry is different. Right now, I think age is the bigger thing.
Yeah, that's the biggest variable is age and how much ash the soils are getting. Yeah.
And then really the elevation, because where the amount of water is hitting it, that plays there with the leaching of the nutrients that really goes down the first thing to go.
Okay.
Yeah. Question.
So I know it's hard to see when you look at brown and werewolves, but also the cold water.
Mm-hmm.
And when you look at cotton, grandma actually got 80% already. So that's why you also see the Mānoa, the concentration in all that stuff.
Mm.
And that's what we've seen because your the Amazon is your that is your
Right.
portion of the pockets.
Mm-hmm. Mm-hmm.
We've noticed is when we start getting the bleed down that level, we got somebody very important. You should,
Wow.
so you're just like getting, you start getting periscopes that kind of show up in the site,
Right. Yeah. That's,
and that makes small.
yeah. Yeah. No, it's something to keep in mind. I think I also noticed like in different ahupua'a that the ku'iwi would almost have like a different construction as well. Some were thicker, some have a lot more cross sections, and that to me I interpreted as like, okay, there's probably a li'i who was telling people how to construct these walls, and ali'i were giving different instructions depending on the ahupua'a, and they're constructed differently because of that. So a lot of, yeah.
And you're gonna get a lot. And the Kula zone and the Fiji was on 100 acres. I mean, they were good.
Yeah.
We'll find hundreds of species per acre. It just mounds hot.
Yeah. Yep.
And if you have time, I would recommend checking out this. A lot of skill books.
Sure.
Those are both.
Like, yeah, I'm sure they probably have a much finer scale map of a lot of the features. Yeah. It's I'd love to check them out. They're not always like public, so they're harder to get your hands on.
They should give Tigers system.
Which one?
Tigers, just a white and go for a sourcing course.
Okay.
You pieces
Yeah, I'll look into it.
on. And if you can get a list of the candidates that get you said, should be or you just go.
Okay. Yeah, we'll do. Thank you. Question.
Great, thanks, Tony Lee. Great talk. I'm interested in more about the function of the core. You mentioned location, mentioned of soil, electricity, and various other things in the more evidence. Otherwise, I learned words about what is used, but they seem different in ways. Finally, and you can get a piece that shows actually more and it's square. What's your sense of that?
Well, I'll lead with I'm definitely not an archaeologist, so I'm not entirely sure, but just from chatting with interested folks, they're designed, I think, differently in Kona than in Kohala, where it was definitely a water management thing. Whereas here, I mean, I suspect it was a much rockier landscape, and you have to clear the fields from rocks, and then rather than just chucking it behind you, you wanted to stack it in an organized fashion to delineate the fields. And then it also probably aided, like maybe that the prevailing wind patterns of Kona were different than Kohala, where in Kohala they come from Mauka, as it's coming over from the channel and comes down Mauka. So you needed that perpendicular wall construction in order to capture the moisture, whereas like maybe the patterns in Kona are different. So maybe the wind's coming from north to south, and you need a different wall construction. So I'm not too sure though. I think work can be done on figuring that one out. I think you were first.
Yeah, I was wondering how the introduction of cattle and how the pigs should, if you did talk about how that intersects and maybe drop bias.
I guess I'll initially mention, like in the Māhele records that I've been reviewing, they all mention the Pāpipi, which is Kuakini's Great Wall. I don't know if you've heard about it, but it was a cattle wall placed there in the early 1800s to keep cattle from going in and eating people's crop. So I guess that's just the first thing that came to mind. But I would say that in terms of preservation, it's been like the ranches, just by the nature of them growing grass, the cattle don't seem to disturb the kua'iwi very much, and they're still very much intact on a lot of these ranches. And in fact, it's mostly these ranch areas that were ranched where I was actually able to map most of my kua'iwi. So it doesn't seem to have much disturbance. It's the development for housing and coffee farms that have really taken them out. Yeah, hopefully I answered your question. Yeah.
Well, we come to our hour mark, so I'm sure we can all be in the last questions. Tommy will be around. Please let him have something to eat, though. And just let's give him another round of applause.
Thank you.
Get a couple minutes to fight some horse out, and there's some water in the refrigerator.